Sometimes are you taking the SAT in September or October and wondering what are some predictions for what could be on the test? My name is Brooke. I've been coaching the SAT for over 2 decades. I've scored perfectly as an adult. I've coached students to perfect scores. We've had students, even in our group classes, get perfect scores in the PSAT. What are my predictions for the SAT for September and October? That's what I'm going to talk about today. If you are prepping for the SAT, make sure you check out our online course at SupertutorTV.com. If you are running out of Blue Book material, which is the best way to predict, by the way, what will be on the exam, our online course is based as closely as we can make it on real exams. It was written by me, plus 6 other professional tutors and a couple other curriculum writers that I picked that had amazing or perfect SAT scores in the sections that they're specializing in. We also have private tutoring, group classes, super seminars. If you're looking for like a quick pop in your score, I recommend you check those out. But let's get into the video today. I do not have a crystal ball, but there's some things that I'm seeing coming up and out of the College Board from their recent question dump that I've also seen on the more recent practice tests that I think my students should know how to do. So my first prediction is possession. We have seen a new possession question drop in the question bank that is testing a possession rule that I have not taught in like a decade, because I haven't seen it on any official SAT questions on any of the digital SAT. So I'm gonna go over that rule. I don't know if that rule is gonna be on the test, but I do think you need to know your possessive rules. I even created a possession cheat sheet for you guys that you can download for free at supertutortv.com/free. You can go check that out. So let's get into this possession rule. I'm gonna show you this question from the question bank, and we're gonna talk about the rule at play. In a recent analysis of lyrical trends in 350,000 songs, researchers cite increases in certain measures, such as the ratio of choruses to verses, as evidence music lyrics are becoming more repetitive. For instance, from 1970 to 2020, blank chorus to verse ratios trended similarly, with each genre's data indicating that the relative number of unique versus the number of repeated choruses in songs increased. So basically, we're repeating more words. But we want to look at this. So here's what's going on, you guys. We have 2 words, and these 2 words have chorus to verse ratios. And here's the trick to figuring out this question. What I have to ask myself is, do rock and rap share a chorus to verse ratio? Or do they each have their own chorus to verse ratio? So I'm going to look right here, and it says with each genre's data. So that to me says each genre has its own data. So the chorus to verse ratios may be different, but they trended similarly. So we're talking about 2 different ratios. That's really important as I approach this possession question. I'm going to get into the rule in a minute after I teach this. Whenever 2 things are distinct and the ratios are different, right? This actually is like rock's ratio and rap's ratio, and they're 2 separate ratios. They're not the same ratio shared by rock and rap. It's rock's ratio, rap's ratio. We have to put a possessive on each of the subjects that are possessing the ratio, right? Because rock's ratio and rap's ratio. So what we do is we say rocks and raps, and the answer is B. But here's the deal, you guys. If the circumstances were different, the correct answer would actually be D. And that would be if rock and rap had the same ratio together, right? So quick example, May and Alma's dog. So maybe May and Alma are sisters. If so, and they share a dog, we would say May and Alma's dog, not May's and Alma's dog, okay? When 2 people, subjects, whoever they are, share something, we only do 1 apostrophe S. Again, I could say May, what if they had 2 dogs that they shared, right? These sisters have 2 dogs. May and Alma's dogs would be correct, right? This isn't a sentence, but you guys get the idea. But if May and Alma are unrelated and they both have dogs, but they're different dogs, May's and Alma's dogs competed in the show, right? That's how we would express that. So in this case, May has a dog, Alma has a dog, or they're different dogs, or maybe May has 2 dogs, Alma has 2 dogs, but they're different. We use this one at the bottom, and that's what we're doing with the rock and rap. If they shared a single dog, though, we would use a different rule. Second thing that I expect to see on the SAT in October or September, actually both, I'm going to be honest, is number of solutions questions. I have seen a number of solutions question on almost every Blue Book exam if you're triggering the hard section. These questions, many of my students do using Desmos, and I will tell you guys that method on these questions can be time consuming. So there is a better way using something called the discriminant. Let's take a look. In the given equation, C is a constant. The equation has exactly one solution. What is the value of C? So here are the magic ingredients, guys. When we have a quadratic equation, thumbs up. And we have number of solutions, 1 solution, 0 solutions, 2 solutions, right? When we have those ingredients, the best way to solve a problem like this is the discriminant, because the discriminant determines the number of solutions. Now, if you're like, Brooke, what's the discriminant again? Opposite of b plus or minus the square root of b squared minus 4ac all over 2a. You might be familiar with this. This is the quadratic equation. If you're not familiar with it, you need to memorize it. Go find some nerdy song on YouTube and play it over and over again till you can sing this in your sleep. Okay, what is the discriminant? It's this piece right here. Under the radical, if that piece is 0, guess what happens? If I have negative b plus or minus 0 over 2a, that's only one solution, and it equals negative b over 2a, right? When I have one solution, that's the solution, okay? It's just that. And this becomes 0. So essentially, I can figure out when this has one solution because this is set equal to 0, right? And if I graphed it on like a y line, what's happening is if there's 2 solutions, it looks something like this. If there's one solution, do you guys know what that one solution always has to be? It always has to be the vertex. Some of you may have memorized that the x value of the vertex is negative b over 2a. Does that ring a bell? That aside, we're not going to get into that right now. All we care about is this discriminant piece because it automatically tells us if there's one solution, right? If this b squared minus 4ac, just to tell you if there's more than one solution, if it's 2 solutions, this has to be greater than 0. Right? And if this is less than 0, then you can't take the square root of it, right? Because you can't take the square root of a negative. So if this is less than 0, this means there are no real solutions, okay? So here's the 3 cases that you guys should be aware of. There's this, and then there's b squared minus 4ac equals 0, and this implies one solution, okay? So there you go. Those are the 3 things. Okay, I'm going to erase a bunch of this just to make some space. So now we're just going to do b squared minus 4ac, okay? And what is this a, b, and c? Remember, this is for ax squared plus bx plus c form. When this is set equal to 0, this is when this discriminant rule works. I have to have this, and it's got to be equal to 0, okay? When those things are true, if it has one solution, this must be equal to 0. So my b is 20, so I'm going to do 20 squared minus 4 times a, which is negative 2, and then times c, which is just c here. I don't know what it is, but we're going to solve for it, right? Because that's what we want, is the value of c. So this is 20 squared, which is 400. You could do that on a calculator if you can't remember. Negative 4 times negative 2 is positive 8. So I get 400 plus positive 8c equals 0. And then I can just move the 400 to the other side. It's negative now because I moved sides. And then I get c equals negative 400 over 8, or negative 50. I'm going to go to the answer choices. There it is. Boom. I have a lot of students, again, who love to plug this into Desmos, but then you're swimming around trying to get to negative 50. And if you're anything like me, when you start off with your equation, you probably only have it at like a 10 by 10 grid, and then you find yourself in Zoom land, and Zoom land is time consuming. If there is one tip that I have for you, and I feel like I repeat myself all the time, do not over Desmos. Desmos is awesome. Learn to use it. Always learn to do Desmos questions. Without Desmos, and discriminant questions in particular tend to be faster if you just use this discriminant tool. I set this up, I plug in, boom, 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 negative 50. Easy peas. The third thing that I expect to see on either the September or October, or actually both, SAT exams is questions where the answer the College Board wants is not x. Instead, it's going to be x minus 5, x plus 7, y plus x, 2x plus 3, something else. A lot of times the College Board throws out what I call like a big ugly chunk that isn't a single variable. Why do they do this? It makes it harder for students to back solve. This question in particular that just dropped into the question bank is kind of interesting as well, because it doesn't even give a distinct answer choice. It gives a range, even though there is a distinct specific answer. There is a single number that's the answer, but they give ranges. So this makes it even 1 degree more challenging. Let's take a look. you see what they're looking for is a range for the value of x minus 5. Not only do they not give you a distinct number, even though there is a distinct number that's the answer, they don't give you x, they give you x minus 5. Why do they do this? Again, it's just more confusing. But best thing for you guys to do is forget about the x minus 5 because it's already hanging out in two places, right? Just think of this as n over 7 equals n over 9. Now here's a cool trick. You can actually just realize that anything, right, divided by number, right, this divided by a number, for these two to be equal, this and this are both going to have to be 0, right? Because that's the only way that this is going to work. Because essentially this is 1/7 times n equals 1/9 times n. The only way that I get a fraction times a number and a different fraction times the same number equaling the same thing is if they equal 0, because 0 is the only thing, right, that if I have these two are the same, okay, then they're both going to be 0. So I can already see that this is 0. I can do this algebraically just to prove it to you, but this is something where when I look at it, same thing on this side, same thing on this side, multiplied or divided by different things, those both are going to have to be 0. So I know the answer to this is 0. That's in that range. A lot of people would put 5 because you can see if this value is 0, x is going to be 5, and they're going to put answer choice C, right? The College Board is out to get you people. So just remember, if you see this, what I like to instantly do is pop an n in just to make sure I don't do the wrong thing. And then you can look at this and say, oh yeah, that's got to be 0. Let's do it algebraically so you guys believe me when I say this has to be 0, because I get that that intuitive sense is hard to build. You may not have it, and if you don't have it, fine, I'm going to do it algebraically. I'm still going to do the substitution where I'm going to set x minus 5 equal to n just to simplify this process so I don't screw things up, okay? So I'm just going to make all of these n, n, and n. So I get n over 7 equals n over 9. I can cross multiply and I get 7n equals 9n. And then I can do 9n minus 7n equals 0. And then I get 2n equals 0. And then I apply what's called the zero product property. What is the zero product property? If I have two entities multiplied times each other, either one or the other has to be 0 for that product to equal 0, right? We've got to have a 0 in the mix. That means n has to equal 0 because 2 cannot equal 0. Cool, and then I get to n equals 0. So that's the algebraic way to do it if you didn't believe me. But now you know this trick where if I have n multiplied or divided by different numbers, okay, that's got to be 0. If I have, right, I can even think of it like this, right? N times a number, or even this, I can even think of it like this, right? If this times a number and this times a number are equal, and these numbers are different, and this variable is the same, it's going to be 0. So if you can skip ahead in your brain, that's like a cool shortcut. But again, expect these like problems where they don't ask for x. They ask for x minus 5 or x plus y or something else. Be on your toes, pay attention. I hope you guys like this video. If so, please give it a thumbs up. If you want to predict what's on the SAT, I have an awesome tip for you, which is take as many Blue Book exams as possible. I swear you guys, those exams are very similar to the real SAT you're going to get on test day. All of these predictions are things that I have seen on actual SAT practice questions from the College Board. That's how I'm predicting this, especially the last two, which I'm seeing over and over and over again. The more authentic practice questions you do, the better. If you're out of those, check out our course, SupertutorTV.com. Go crush your SAT. Let us know how you did. Tell me in the comments if you have ideas for videos. We would love to make them. I'll see you guys soon.